Good afternoon, ladies and gentlemen. Welcome aboard. This is Claire from Neoventure Corporation, the organizer of the webinar. As a clean and renewable energy, solar energy is valued and applied in many countries and regions in the world, as well as in Chinese Taiwan. Today, we are gathering here to listen to some important players and experts to share insights about Taiwan solar development. First, I would like to give a brief introduction and big welcome to our speakers today. They are Mr. Paul J. Kensingham, Senior Legal Consultant from Iger Law. Paul, before joining Iger, he was a partner at various international law firms in the United States, Hong Kong, and Chinese Taiwan. Paul has represented US, European, and other multinational companies conducting business in the Asia-Pacific region for the past 35 years. His clients are active in many sectors, ranging from pharmaceuticals, consumer products, biotech, energy, and others. And Mr. Charles Wang, Sales Director from SMA Great China. Mr. Charles graduated from the University of New South Wales in Australia with a master's degree of photovoltaic power generation and solar energy. He joined SMA Australia in 2010 and engaged in product after sales service and served as sales technical support in 2014. In 2015, he joined SMA China and currently is a sales director of Great China, responsible for business development in Great China. And Mr. Lin Chongbo, head of product and marketing APAC from Trina Solar. Lim is handling product and marketing in APAC at Trina Solar. He joined Trina in November 2011 and has been responsible for product management, training, and promotion of new products to APAC customers. He has over 9 years of PV industry experience and sporting a broad base of customers in different segments on product and technical matters. And for today's webinar, we will have 3 20-minute plenary speeches given by Mr. Paul J. Kensingham, Mr. Charles Wang, and Mr. Lin Chongbo. The organizer of today's webinar, Neoventure Corporation, is dedicated to supporting key investors and developers for successful development and investment in Asia-Pacific renewable energy sector. Our footprints cover Asia-Pacific countries such as Vietnam, Philippines, Thailand, China, Myanmar, Australia, Malaysia, Singapore, and some Middle East countries. Before starting the webinar, I would like to introduce all attendees with some housekeeping notes. If you experience any technical issues or having questions for speakers, please use the below Q&A box. Also, we will share the presentation slides and webinar recordings with you by next week through your registration email. Now let's move to the first speech. And in this session, we were offering bilingual channels for you to choose. Let's welcome our first speaker today, Mr. Paul J. Kensingham. Let's welcome.
Good afternoon. All right, could you bring up my PowerPoint slide? All right, thank you.
Just a moment. Okay. Can you show my screen?
Great.
Okay.
Good afternoon. Back in 2017, the Taiwan government took decisive action to phase out Taiwan's reliance on nuclear energy. The government announced a plan to eliminate nuclear power, increase Taiwan's consumption of renewable energy to 20% of total consumption, and increase Taiwan's installed solar power generation.
让台湾光伏的装机容量大幅增加至20吉瓦。从光照资源的角度来看，台湾的光伏资源是非常充足的。 特别是中部和南部地区，然而相对的，台湾的土地资源较为稀缺，这也导致了台湾光伏项目的法律框架较为冗长且复杂。
Framework for Taiwan's solar energy projects. Taiwan's solar projects include both ground-mounted and rooftop projects, both on government-owned and on privately owned land and buildings. Developers include both Taiwan Power Company, or Tai Power, the government-owned grid operator, and various Taiwan and foreign-owned private developers. These variations in type of developer, type of project, and type of owner of the underlying asset all contribute to the complexity of Taiwan's solar energy regulatory framework. As of the end of last year, Taiwan's installed solar energy capacity was about 5.8 gigawatts. This represents definite progress, but slow progress toward the government's official goal of 20 gigawatts by 2025. Next slide, please. Here's a map that identifies Taiwan's solar power installations as of July 2020. A few conclusions are clear. First, solar energy projects have been built throughout Taiwan, including on a number of small outlying islands. Second, most Thai power projects, and of course it's a Thai power map, so there's a lot more detail about Thai power projects, are less than 2 megawatts. Third, in most cities and counties that have both Thai power projects and privately developed projects, the capacity of the private projects is much greater than the Thai power projects. The Taiwan government has also taken action to increase the demand for renewable energy. Beginning in 2025, most businesses which have signed contracts with Thai Power for delivery of 5 megawatts or more of electrical power must generate or purchase at least 10% of their power requirements from renewable energy sources. It appears likely that many business users will purchase solar power from private developers to fulfill this new legal obligation. I'd like to comment on two major types of legal considerations for solar energy projects in Taiwan: corporate business structure issues and solar power regulatory issues. Both of these topics are very large and very detailed, so all I can offer today is a general introduction to a few key issues. Proper legal advice would require a full understanding of a project's background facts and of developers' goals. In addressing legal considerations, one size definitely does not fit all. Next slide, please. First, corporate business structures. In general, any local or foreign investor may incorporate a Taiwan company to own and operate a solar energy production business. A foreign investor may choose to set up a joint venture company co-owned with a local investor, but a local investor or local business partner is not legally required. Before a foreign investor sets up or invests in a Taiwan company, the investor first must obtain foreign investment approval, or FIA, from the Investment Commission of Taiwan's Ministry of Economic Affairs. FIA is usually granted routinely for foreign investments in Taiwan solar energy production, though the requirement to obtain FIA needs to be considered in preparing timelines and expense budgets. The major exception to this general rule of routine FIA is that FIA is not available for solar energy investments by companies incorporated in the People's Republic of China or owned by PRC investors. PRC investment into Taiwan solar energy production is effectively prohibited. Next slide, please. Many foreign investors utilize an offshore holding company to hold their Taiwan investment, whether in solar energy production or some other business. Such a holding company
这种
allows
控股公司可以允许海外投资方引入其他资方来共同参与项目投资，或秘密出售其部分或全部的投资。在没有
company any new investment or any transfer of the original investment would involve a change in ownership of the Taiwan company's shares. An additional FIA would be needed for such a change in ownership, adding time and expense and resulting in disclosure of price and other terms of the investment transaction. If an investor invests in more than one Taiwan solar energy project, the investor usually incorporates each project individually. This insulates the assets of one project from the liabilities of another project. It also adds flexibility in allowing the original investor to bring co-investors into one particular project, and makes it easier and more efficient for an investor to sell its interest in a single project. Also, a foreign investor with multiple projects might decide to have the shares of each project company held by a holding company incorporated in Taiwan. Dividends from a Taiwan company to a foreign shareholder are normally subject to withholding tax. If an onshore holding company is used, dividends from one project can be reinvested into another project without paying withholding tax. In the absence of an onshore holding company, dividends from each project would be subject to withholding tax, often at 21%, and only the after-tax balance could be reinvested back into another project in Taiwan. Finally, decisions about corporate business loans can be either a single or a syndicate of in advance whether to finance each project separately or finance all of the projects together as a group. If different projects have or may acquire different co-investors, the co-investors likely finding project. On the other, especially if a lender may prefer to all projects and take collateral on projects to secure all debt. Lender insists on using its standard documents rather than prepare custom-driven financing. People at standard forms may be suited for finance. The second type of legal consideration I'd like to discuss is solar power regulatory issues. I wish I could make this topic exciting, even funny, but I'm sorry, I'm not good enough entertainer to do that. Please bear with me though, and I'll do my best to be informative or at least brief. Next slide, please. Here's a list of some of the key regulatory issues that need to be addressed in most or all Taiwan solar energy projects. These issues aren't listed in chronological order. The chronology for a particular project is usually longer and more convoluted than this simple list suggests, because preliminary approvals from one authority are frequently prerequisites for approvals from another authority. Next slide. Thus, an investor often needs to zigzag back and forth among the various authorities that share jurisdiction over different aspects of the solar energy project. I wish I could tell you that there's a single window that handles all solar project government filings, but there isn't. And one other bit of bad news, many of the approvals have expiration dates. Some can be renewed as necessary, but others need to be, quote, used to complete some subsequent step in the application process before they expire. Thus, an investor must keep in mind various mandatory time limits throughout the regulatory approval process. Next slide. Okay, so let's begin at the beginning. A solar project to be built on government land or the rooftop of a government building typically begins with a government-issued request for proposals. Such an RFP typically requires bidders to submit their plans and bids within a very short period of time. The terms and conditions spelled out in the RFP are normally not subject to negotiation. A bidder normally identifies the peak capacity of the project it proposes to build and the percentage of its revenue it proposes to pay to the government owner of the land or building. In many or most cases, The winning bidder is the bidder offering to pay the most rent to the government land or building owner. Thus, the bid is a function of both peak capacity and the rental rate. A losing bidder may file a bid protest, but protests are not common. And of course, there's no competitive bidding if the land or building is privately owned. Second, the issue of environmental impact. Taiwan's Environmental Protection Administration requires a detailed environmental impact assessment if a solar project is to be built on protected wetlands. EIA can be an expensive, time-consuming, and ultimately unpredictable process. In many situations, an investor may be well advised to abandon a site and search for an alternative if it discovers that EIA approval will be required. Third, acquisition of access to the project site, land, or building. The process of acquiring legal access to a project site depends on whether the land or building is owned by the Taiwan government or one or more private owners. If the property is owned by the government, it normally is administered by the National Property Administration. In this situation, an investor must obtain a consent letter from the NPA early in the regulatory process. Much later in the process, after the Bureau of Energy has issued an establishment permit for the project, the investor and the NPA must enter into a standard form administrative contract. The investor must post a bond with the NPA, both at the time it obtains the initial consent letter and at the time it signs the administrative contract. One of the major headaches an investor can face in the acquisition of access to government land is the possible presence of tenants or squatters on the land. The NPA may have signed formal leases with some of the occupiers of the land, and other occupiers may have acquired a statutory right to remain on the land based on the duration of their occupation and other factors. In such situations, it's the responsibility of the investor, not the NPA, to negotiate with the tenants and squatters to terminate their leases, waive their statutory rights, and leave the land. In fact, the NPA may not even willingly share what it knows about the occupiers on the land or the duration of their occupation. The investor may be completely on its own to deal with third-party occupiers. Access to a privately owned project is simpler in theory, but not always in practice. In some situations, it may be feasible for an investor to buy the land or building where the project is to be built. More often, though, the investor prefers to preserve capital and lease the project site instead. Unfortunately, an investor planning to lease a project site may need to sign leases with many owners. Under Taiwan law, a building may be owned by someone other than the owner of the underlying land, and there are differences in the rights of a building owner to use the land to access the building. To add to this complication, land may be divided into small plots, with different plots owned by different members of the same family. Or a particular family member may have informal control over all of the family's land, even if he or she is not the registered owner. Similarly, rooftop access may be shared by all owners of the individual condominium units in a building. Some owners may be happy to lease their property to a solar project investor, while other owners may be opposed in principle or may hold out for more money. Thus, an investor may need to begin making payments to some owners, not knowing if or when other owners will agree to a lease. And finally, after the investor has signed all the necessary leases, a risk still exists that a prior mortgagee could ask a court to terminate the leases as part of a mortgage foreclosure proceeding. Fourth, grid connection and sale of power. These issues involve the project company's relationship with Taipower. Grid connection may or may not be a major issue, depending on the proximity of the project to Taipower's grid and the grid's capacity at the connection point. If adequate Taipower facilities are already in place, grid connection may not be an issue. On the other hand, if Taipower needs to construct additional facilities in order to connect the project to the grid, the project company may face uncertainty as to when the connection will really be feasible, and Taipower does not offer capacity payments. As I mentioned earlier, it's likely in the future that solar project companies will enter into direct power sale agreements with large private power users in Taiwan. These direct sale agreements necessarily include an integrated set of 3 additional agreements with Taipower: a wheeling contract under which Taipower delivers electricity from the solar project to the end user, a supply agreement under which Taipower buys any power the project produces in excess of the user's demand, and a residual PPA under which the user buys from Taipower any electricity the project cannot supply. If the project company doesn't enter into a power sale agreement with a private end user, it normally enters into Taipower's standard form PPA, agreeing to sell its energy to Taipower in exchange for payment of the relevant feed-in tariff. However, solar energy tariffs are adjusted downward every 6 months, and a project's FIT isn't locked in until construction has been completed and the project is to be connected to Taipower's grid. This can create a challenge for financing solar energy projects. Investors and lenders must commit most of their funds before construction begins. At that time, the applicable FIT, and therefore the project's 20-year revenue stream, remain uncertain. Investors and lenders can do their best to estimate when a project will be completed, but any delay in construction, for whatever reason, can translate into a lower FIT and jeopardize the project's revenue potential. Next slide, please. 5th, local government approvals. I'm running short of time, so I'll keep my comments on local government issues brief. Local government authorities have jurisdiction over zoning and other land use considerations. But local authorities are often the place where neighbors, business associations, would-be suppliers, and other third parties can make their political influence felt. Also, local government officials don't always feel constrained by national government.
台湾政府对于大力发展可再生能源的政策限制，因此根据具体情况，说服当地官员以及当地地区是非常重要的，甚至是很必要的。 最后一点是关于能源局，也就是 BOE 的相关内容。BOE 主要负责
including an establishment permit, an equipment approval letter, a construction permit, and finally, when construction has been completed, the project's electricity enterprise license. Essentially, the BOE's responsibility is to make sure the investor's plan makes sense, that it will install appropriate equipment, that it's adequately financed, that it has obtained all of the other approvals the project requires, and that it has the necessary technical staff to operate and maintain the project after it has been built. Other steps in the regulatory process apply in some circumstances, but not others. Is the project to be built on coastal land or in an urban planning area? If the land is agricultural, is it land suitable for farming or not? If the project site is a rooftop, is the structure legally licensed as a building or is it just an illegal construction? All of these questions matter, and in a specific case, they can change or supplement the general regulatory outline I've described. One final detail, maybe more interesting than my general explanations. The Taiwan government has recently launched a program to combine solar energy production with aquaculture, that is fish farming. In general, farming, including fish farming, may only be conducted by properly licensed Taiwan nationals. Foreign investment in farming is prohibited. However, in 6 locations in Taiwan, a solar energy investor, including a foreign investor, may now enter into a cooperative arrangement with a fish farmer. Up to 40% of the farm's fish ponds can be covered by solar panels, as long as the fish production remains at least 70% of its historic average. The program is new, and there are still some unanswered questions, such as what happens if there's a sudden shortfall in fish production for reasons having nothing to do with the solar facility, or what happens if the farmer retires or passes away. Nonetheless, it's a sign that the Taiwan government remains committed to solar energy and may even bring a bit of creativity to its efforts to encourage the further expansion of the industry. Thank you. Last slide.
Thank you, Paul, for insight sharing about Chinese Taiwan solar development from perspective of laws and regulations. And now let's turn to the next speaker, Mr. Charles Wang. The topic of his speech will be PV inverter selection and design recommendation. Mr. Charles will use Chinese to give a speech while showing his presentation with both English and Chinese. And if anyone is interested in SMA, please be free to contact him by his information on the screen directly or use the Q&A chat box to leave your message. Okay, now let's welcome.
Thank you, Claire, and thank you, Paul, for that brilliant presentation. 我现在会用中文去跟我们这个线上的所有的业界的先进来稍微介绍一下我们 SMA 接下来对于这个台湾一些大电厂的变流器选型，还有可能接下来对于一些大模组、大功率的模组去做一些适配的一些动作。那刚刚 Claire 有讲到，如果你们是比较习惯听英文的话，那右下角这边可以转换成这个频道的切换。好，那我们就开始。那今天我的这个简报呢，主要会先提到我们 SMA 对全球台湾的这个那包含说我们的集团的一些新的信息台湾的市场关注度，也会提到说 SMA 之所以能够在这个业界里面保持关注度，那我们肯定有我们的一些优势，我会把这些优势给稍微点出来。那第二个部分呢，就是我们在台湾这边主要用了几款最重要的一些机型都是经过 VPC 认证的，还有更重要就是在不同的专案的这种情况下，会有一些不同的布局设计。那主要就是说是在像比如说地面型的时候，那会有一些比较适当的一些用组串式的方式去做到集中式管理的一个概念。那最后一个部分就是我们的一些比较特别的一些已经做好的一些案场的分享那这些有一些是海外，也有一些是在台湾。那 SMA 在2021年的部分主要我们在第3季结束的时候，我们做到大概是6.8个吉瓦的 inverter 的变流器卖到全球。预估在2021年结束的时候，应该还是10个吉瓦，跟去年是差不多类似的这个数字。那在2020去年的时候，我们也是有卖到刚好今年是我们是1981年诞生的，那刚好今年是第40周年，所以在太阳能的业界能够撑到40年不能说撑了，但是能够在40年的屹立不摇，其实我认为应该我们也是蛮了不起的一个成就了，这个是我自己这么觉得。对，那在台湾的部分呢，我们累积的出货以及安装这个加起来已经超过了500个兆瓦。 对，那其实这也是一个蛮难得的一个成就，因为毕竟台湾的市场，它不像中国大陆或者是像美洲、欧洲市场这样子，那能够这几年下来有这样子的累积的安装量，其实也是一个蛮不错的一个的成就。那在2021年的时候，我们在出货也超过了130个 megawatt， 包含说有一些很大的地面型电站等等的。那因为在台湾所有的设备现在都需要做所谓的 VPC 的这个认证，因此我们的认证也就是从25千瓦到150千瓦都有，这个在之后会再提到。刚刚有讲到我们 SMA 的这个也不算短的40年的一个历史，从1981年开始，那个时候的其实我们还是在做的是电车里面的这个直流转直流交换器，一开始还不是在做，但是我们在1987年的时候一款的这个变流器蓝色的这在左边蓝色的这个，当时很大，这一台看起来很大，可是实际上它只有700瓦而已。对，所以它其实你可以看到，随着时代，而且那个时候都是手工做的，所以这个随着时代的变迁，当然这个科技的进步也是非常的可怕。那比较另外值得一提的是，在2001年的时候呢，我们 SMA 也是做出了全球第一个这种储能型的接这个我们叫 Sunny Island 黄色的这一台，它是第一款能够做到所谓的离网的，就是把离网项目、离网的这个系统就是等于说是当你没有电网的时候，可以直接透过电池转换成交流电，提供给现场的负载，因为负载大部分都是交流侧来使用，这也就是说我们在储能方面其实也是超过了20年左右的经验了，所以也是非常非常的古老，就已经有在做这个部分。那在2002年的时候，我们做了第一款集中式的变流器这个时候一款变流器那时候是100千瓦或者一样就是250千瓦，就是现在你再来看回去，这些都是可以做成主串式的，但在当年都是还是很大的一台。那在2008年的时候呢 ，SMA 这个在德国的这个 TechDeck 这边也已经正式宣布上市所以从2008年开始，我们也是有这个在当年的最大的一个 IPO。对，那接下来当然从2011年开始，我们就几乎都是以3项的这个机型，当然是还有包含没有变压器的，以前的机型可能都有很多变压器 transformer 在里面。那因为了要减重，为了要这个提升机器本身的效率，从2011年开始，我们也是做出来第一款这个3项的变流器是可以达到99%的这个效率。那在2016年的时候呢，我们也是做了这个我们叫 Sunny Boy Storage， 就是它也是一样，它是一个小台的储能的变流器，也是接这个蓄电池，然后也是可以直接提供给这个交流负载来使用，就变得更小台了。那在2019年去年不好意思，2019年的时候呢，我们做到也是全球当时最大的一台是4.6到1600千瓦的这个集中式的机型。去年我们今天也是今天的主角之一，110千瓦的12路 MPPT 的这个3项的主传。那SMA 之所以能够在这个产业这么久，毕竟我们还是有在不断推出新成的产品。身为一个老牌的德式企业，我们绝对不是靠价格，一定我们是靠我们所谓的技术。那什么样的技术呢？这边我们分成了有3个不同的面向第一个当然最下面的还是以我们的核心业务，也就是我们的硬体的变流器，包含说是刚刚讲到的跟太阳能有关，或者是跟储能有关的这个的变流器当然还有一些其他的零配件包含说电表等等这些的。那中间这个部分呢，就是我们 比较特别。刚刚也讲到了这个下面的这个核心业务，很多家公司都可以做得到。对，这也是为什么接下来越来越多的这个，比如说中国大陆的公司也好，或者是海外的公司也好，都慢慢在进到变流器的这个业务。但是在上面的这2层可能就慢慢会比较少有这个竞争上来讲会比较难。那中间的部分呢，是我们刚刚讲电网服务这个甚至像是有一些特别的特别国家他们要求的一些政策，说比如说需要太阳能 PV 零输出，或者是 PV 平滑化或者甚至到夜间需供补偿这种比较所谓功能，就是一些在特殊的一些应用下要求变流器提供一些功能。那这些功能当然 SMA 也是算是会在比较早期就把这些相关的功能放到这个变流器里面去。这其实有点就像是去之前讲到的时候，比如说你去买宾士 Mercedes-Benz 的汽车来讲好了，你可能在20年前你去看到 Mercedes-Benz 的汽车，它可能就已经不只是安全气囊或者是一些特别的一些新的一些东西，但你在现在来看，你可能会觉得这大家每部车都有，但是在20年前可能我们就已经有这样的构想了。同样的，在变流器上也是一样的概念。那最上层这一端是我们的软体跟云端平台。那这个云端平台这边也是一个蛮重要的一个部分，因为它可以让这个所有的客户群体创造当然更多价值，而且是用数据的方式连接在一起。那同时我们也有做一些软件的方式，就是比如说透过我们 MPPT 就是设备本身的 MPPT 的特殊的演算法叫 ShadeFix 去增加我们的这个发电量还有所谓 NXOS 就是这种所谓的这种云端平台，可以把所有这些数据透过网络上传到网页上然后让客户可以去看到这样子。对。那另外一个最重要的当然除了技术以外就是我们可靠性。我们可靠性对 SMA 来讲这是一个非常非常注重的一个部分。所有的设备本身我们会经过非常严格的这个规格测试简单的一个讲法就是说多部分测试呢是会热冲击thermal shock 的热冲击的方式去做。那这边的部分呢是我们刚刚有讲到，就是说每一台机器本身我们都会做例行的测试。那当它在做一个测试完之后，在每50台里面我们会抽1台去做所谓的耐力，每1000台里面有1台我们也会去做所谓的电热应力的这个测试。那这个部分就会相对来讲，每10000台里面会抽1台我们去做这个温度冲击测试。基本上温度冲击测试跟这个异常测试这2个部分就是已经是会做所谓的破坏性的方式了。那破坏性的方式那当然相较来讲是会比较对于设备本身测试出它在极端环境下。那我们刚刚第一段讲完了，我们现在第2段呢就是讲有关我们商用变流器的这个方案那这个部分的话呢，首先一开始我们会先讲到说，在台湾有4款，目前有应该算5款了设备是做完 PPC 认证，而且随时都有到的，从25千瓦一挂型老牌的设备，10千瓦这个在这个堕落型在地面上的这个最新款110千瓦的这一款产品。那这3款是我们3项变流器是比较是所谓的多路 MPPT， 它比较适合屋顶型这种可能会有一些遮阴等等的，它包含说我们刚刚有提到的我们的 MPPT 里面内容还含有我们最新的这个演算法叫 ShadeFix， 可以在这个遮阴的这种情况下呢，可以达到最高发电量的这个预估跟这个演算那这是比较多路 MPPT 的这一个系列。 那我们还有一款是说在右边这个叫 Peak 3，这个是我们的3项变流器，但它是单一 MPPT。那它单一 MPPT 呢，它的意思就是说，它其实是比较适合是用在地面型跟水面型岸场的一些专案。那它的目的是在于说，较少遮阴的情况下，它用单路 MPPT， 它就已经可以达到一定的发电量的一些效益了。那减少它的目的当然是为了希望能够减少这个相关的一些零组件因为当然你越多 MPPT， 你所有的零件就要更多嘛。对，那更多，那当然你相对来讲你的这个可能的一些损耗就是内部的损耗比较多。对。那我们这个部分的话，我们是有100跟150千瓦，待会这个我们也会详细的介绍。3原则上它是目前我们也就是我们在台湾用专案在使用的话，都是100最大的功率的产品。那它比较特别的在于说，它的直流侧是用1500伏去。为什么要这么做呢？因为当然1500伏，目前全球来讲，对于大型案场上，也是比较的一个规范。那当然从这个 EPC 或者是从投资方的角度来讲，1500伏的系统也能够在某些程度上能够降低非常多的成本在直流侧包含线材啊，包含这个功率啊等等这个部分。那设备这个本身呢，当然也是有达到99.1%的这个效率，因为它是壁挂式的，所以非常容易安装两个人旁边我们会有装一些手把，让2个工程师可以在比较容易的情况下去用壁挂的方式把它挂起来。那当然肯定，因为装这样的设备，它肯定不是只有1台，它肯定是有很多台在现场。那我们就是用所谓的一个集中式管理的概念等于说是用一个中央的，比如说不管是控制器或者是用 SCADA 系统等等的都可以，它都可以用我们的这个 Data Manager， 我们的数据采集器去将所有的数据给下载下来，或者是说用一个如果是需要下一些指令去做一些调控不管是这个 PQ 调控，或者是做一些功率的一些输出的降低功率等等的一些要求的话，都可以由一个地方去做这个所有的这个执行。对，那它是用以太网路线的方式去连的，那还有包含说我们所谓的公开的这个 Modbus 的 TCP 的通讯协议。那这个部分呢，是我们刚刚讲的所谓的集中式管理的概念，我们也比较推荐是所谓使用像这样子这种安装方式，看这2种不同的这个是所谓的分布式，是比较传统型的做法，变流器装在模组变阵列的旁边，那装在旁边，然后拉一条交流线去拉到那这个在小型的系统是 OK， 没有什么太大问题。但如果在大型的这个情况下的话，你会发现说，因为我们通常直流交流都会有一个所谓的直流交流配比，那直流通常会比较高，我们就假设今天是24个兆瓦，24 mega 瓦好了。那因为变流器本身是我们假设这边数量是有达到20 mega 瓦的一个数量，这个情况下呢，因为就会有所谓的线损问题，所以你在变流器在输出的时候就是20个 mega 瓦没有错，但是因为经过了这个长的这条线到达你变压器转出到11千伏或者23千伏的时候，它会低于20 mega 瓦，它会低于20个兆瓦，这是必然的，因为它是有一个线损的问题在这边。另外还有一个比较严重的一个部分，通讯，因为当你通讯的部分也在机器本边，因为这都是在这个阵列里面嘛。那如果是这样的话，我们通常会建议这个拉的这个距离要拉很长。那你线如果一旦拉到太长的话，会导致没有办法，会有一些那 最好的建议的这种大型的这种集中式这种像类似这样子的做法，就是把变流器安装在这个变压器的旁边，然后在这个太阳能模组的这个串列阵列这边呢，我们是装流箱。那装直流汇流箱的用意就在于说，它是拉直流线拉长，拉到变流器。那就变成说，同样的，我这边还是24个 megawatt，24个兆瓦，但我用拉直流线过来到变流器这边，会有一个顺一样的线损，没有错。但是因为我有一个直流交流配比，我会配比较高，比1.1或1.2，所以导致我这边出来的部分，只要它的线够短，它直接到变压器，相较之下，它是可以达到20个 megawatt，20个兆瓦左右，就跟上一个比起来是会有差距。那同时间，因为我的这个通讯线呢也是拉的比较短，所以在这个部分会比较有。这个在双面模组的情况下呢，双面模组当然这个变流器本身我们并不是专家，待会这个天河的这个经理来这个做更详细的介绍。但原则上我们来讲，就是说对于双面的太阳能模组对变流器的差异有什么样的差别啊？对我们来讲，双面模组它的背面，因为它是玻璃板或者是透明片，它可以额外经过反射光额外的能量，那增加输出。那其实原则上最好的其实是雪啦，但是因为在台湾可能不会，大部分这边的情况，可能大部分可能只有在水或者是水泥，它这边就会有一个，这是 TUV 的报告上面会有写。那这个比较跟如果是普通的没有这种双面的这种比较的话呢，以一个100千瓦的一个系统来看，我们用一个500瓦的模组，那其实差别就在于说，如果你有双面的话，你可以把大概7到10%增加，这个是我们是以放在草上面。那跟没有这个双面的这个模组来比较的话，你可以减少大概14到20片左右的这个模组然后达到相同直流的功率的输出所以这个相较来讲，这还是会有一些优势的。对，那对于变流器这边来说呢，其实对我们来讲很简单，我们只是看说，当你今天增加这个额外的比例之后，你是不是能够达到，会不会超越我们在规格书上面写的最大的直流建议的直流功率？那这个直流功率呢，像比如我们100千瓦的话，我们的最大直流功率是150。说我们厂商建议的直流交流配比是最大是到 1.5， 就是 150%， 这已经也是算蛮大的了。所以因此你怎么样设计，应该也不会说涉及到这个部分。所以因此呢，对于 SMA 变流器来讲，所有的双波模组就是其实不会有，对于变流器不会有任何的问题。好，这个案例是我特别这边放在这里，是因为说希望能够让大家看出双面的这些模组在特殊的应用下其实非常好用的。这个地方是在南极的伊丽莎白的，大家可以看到它的模组是接近快要到立起来的这个状态。那他当时就是用这个 Kyocera 的这个因为这个地方是还包含说有风力发电以及这个柴油机，当然还有我们的整个储能的，所以它是一个混合性的一个系统，在一个非常严苛的环境下，那当然这个部分也是为什么会使用 SMA 的一个主要原因。那另外一个比较更重要的部分就是我们现在大家都在讨论到的，不管是182或是210，这个模组，当然这个比如说我们今天是以跟天河来比的话，210 mm 的这个模组呢，它就是至少是在500到550瓦。现在当然有更高的啦，我们当然想说接下来可能会甚至到600或到700这个的部分。那大功率模组呢，它比较当然 对于这个 EPC 跟投资方来讲，会有比较低的 LCOE 的成本，这个 BOS 的成本较低，那这个能够当然提供高功率的这个性能，还有长可靠性这样子。那更重要的就是说，变流器要能够兼容这个部分。那变流器要怎么样兼容呢？这个要看在什么地方呢？那这个就是我们会关注在就是以模组来看，我们会关注在 MPP 的 IM 就是这个电流的这个部分，就是每一个模组它的电流的这个部分。那对于我们的变流器来讲，它有一个最高的这个限制。那因为我们的150千瓦它是单一 MPPT， 所以它就没有这个问题，你就可以用很多串去做到这个目标。所以像以这个刚刚讲的这个模组来讲，最终是低于180安培。对于单一 MPPT 模组来讲，单一 MPPT 的这个变流器来讲，对于大模组是没有任何的适配。刚刚另外我们讲到一台，就是我们说的110千瓦的这一款产品。那110千瓦它比较特别，就是它有12路 MPPT。那同样的，它的超配比是150。那这个情况下呢，它到底是有发生呢？那同样的，我们因为这款产品它的12路 MPPT， 每一路它有2端口。那一个端口呢，如果今天你是用普通模组大家都在10安培以下嘛，那就没有问题，就每一个 MPPT 它都可以接2，因为它每一个 MPPT 它有它的限制是20。如果你今天是用大模组的话，就像我们右边看到的，那其实因为假设它今天是18安培，那你可以接1串就好，你还是可以接12串。那这种情况下的话呢，它的这个因为它功率比较大，所以它功率大，你数量只要它的电压能够保持在800到900伏，原则上它的功率是绝对可以超过110千瓦。所以原则上就是说，我们总结来讲，SMA 的产品，不管是多 MPPT 的这个设备，或者是单一 MPPT 的设备，对于未来的大功率的组件模组是都没有任何的这个适配方面的配置方面的问题。最后的部分呢，我们就稍微快速的讲一下我们这个一些介绍。那这个是我们用 P3 去做这个在美国或这40台加80台，总共120台，在阿拉肯萨斯州这边去做的地面型的一个电站。它都是用在地面上，然后全部聚集在一起。刚刚提到的变压器，所以能够极大化。这个是在英国也是一样，用同样的方式、同样的设计去做这样，希望能够达到。那这个是在德国，那德国的话，因为它这个是有在 Bavaria 在包含风能电厂去做一个。这个也是用55台的。然后我们切换到台湾，那台湾的话呢，我们在台南这边我们有做一个养殖场的部分，这个已经超过5年的时间了。当时蛮大，就是2.86的这个。另外就是我们今年年初这个完成的这个68 MW 的在台南学甲的新中电厂，它也是直接把 P3 刚刚讲到的这一台产品直接安装在我们的20尺柜里面，然后它里面再另外加风扇去做。为了这么做，是因为为了抗特殊的一些环境。一样做一个集中式管理。最后这个专案比较特别，就是说它是一个储能的设备。那这储能设备它是一个 AFC 的这个调控的这个备转服务的专案。据了解，这个方案从今年开始到目前为止达成率都是到 那我今天的分享就到这里，各位有任何问题的话，
Okay, thank you, Charles. Thanks to SMA for bringing their solutions to the Taiwan solar market. Next, let's welcome Mr. Lin Chongbo from Trina Solar to share their state-to-the-art technologies. And we also provided English channel and Chinese channel at the same time. Let's welcome.
Thank you. So let me share my screen. Okay, I hope everyone can see my screen now. So once again, thank you to the speakers and also Neoventure for organizing the webinar.
各位下午好，首先感谢大家参与这次线上研讨会。
I'm Lim from Trina Solar. So today
我
I'll
的林超文，目前
give a brief introduction about
你
Trina
的
Solar.
产品和营销工作。
The PV applications for Taiwan market. Okay, just a brief background on Trina
它
Solar
的
as a
背景给大家做一个简单的介绍。Trina Solar 于1997年成立，我们目前在光伏行业内有超过20年的资深经验。
happen in
在
the
Trina
program.
Solar 的发展历程中，我们最重要的一个里程碑，就是在去年
Relisted ourselves onto the Shanghai Star Market and also launched the first 600 watt module into the market. So in terms of globalization, we are well covered on a global basis. So for Asia Pacific wise, our HQ is in Singapore, and then we are supporting the APAC region from there. So cumulative shipment wise, we have shipped more than 70 gigawatt worldwide as of Q1 this year. So we have more than 100 over customers globally and about 50,000 employees that is working with Trina. So in terms of branding, we are ranked 6 times in a row top most bankable module supplier by Bloomberg New Energy Finance. So I think that is a good achievement from us. We are bankable and definitely can be considered for the different solar projects. So in terms of Asia Pacific wise, over the last 3 years, we have shipped almost 9 gigawatt and definitely one of the top 3 players in Asia Pacific. So you can see from a map here, we are covering APAC, namely from India side all the way to ASEAN, then also Australia and up to Korea. In terms of leading technology, we have launched our products using the 210 mm wafer and also using different innovative technologies into our modules. And at the same time, we are also working on the N-type I-TOPCon mass production. So this will be happening.
并预计会在今年第4季度发布。我们也正在积极的对 HJT 技术进行研发，并期望将这项技术带入到大批量生产中，从而为我们的客户带来更多的价值。
efficiency of HJT cell in our mass production. So this might happen sometime in 2022. So just a brief background of how
接下
module
来我
power.
给大家介绍一下过去10年里我们的组件技术发展足迹，特别是在过去的2年内，我们将组件的功率从500瓦大幅提升至接近700瓦。
Different module manufacturers incorporating large wafer size and different new technologies into the module. So now we are seeing power business of between 500 watt all the way to almost 700 watt. Then we do see another interesting trend is that since
也是在今年6月份，我们在中国的 SNEC 展会上也看到了很多企业都开始使用210毫米光伏组件，功率大约在600到700瓦左右。因此，我们也可以看出这是光伏市场上未来一个逐渐增长的趋势。对于 Trina Solar 来说，我们已经在供应210毫米光伏组件了。这类组件我们已经供给了欧洲、中国以及东盟地区的一些国家和区域。部分由 Trina Solar 供应了210毫米的光伏组件的项目，为位于新加坡的60兆瓦项目，以及另外几个位于越南的项目。现在大家看到的是 Trina Vertex 系列全部组件规格，共有5个。 左侧第一个是 Vertex X 系列，功率相对较小，为405瓦，主要用于民用住宅光伏市场。
21 series, this is for ground-mounted. This is a comprehensive product model list that we have that has already obtained Taiwan local certification. So this can be used for your projects in Taiwan. So in terms of the innovative technologies, starting from the top left corner, we can see we are now using the largest wafer size in the market, which is 210 mm. So to match with this large surface area, we have also used multi-bus bar. So most of our higher power beam modules are now using 12 bus bar. And together, because the cell becomes bigger, we have also changed from conventional laser cut to using a non-destructive cutting to achieve the half cell. So the advantage of this is that when we use this non-destructive cutting, we're able to maintain a similar mechanical loading properties as compared to a non-cut cell. Then on top of this, we have also incorporated our high-density interconnection technology. So this technology essentially is to minimize the gap between each cell so that we are maintaining it to about between 0.5 to 0.9 mm spacing between each cell. So this will enable us to reduce slightly the dimension of the module and help us to maximize the efficiency. So just a bit more details onto our specific product range. So this is our Vertex S 400 watt module. Essentially, this is mainly used for the residential rooftop. And you can see just a simple comparison why we choose this to offer this product is because it's able to offer a good power beam, about 400 watt. Then in terms of the dimension and also the weight, is the most optimized for the smaller residential rooftop. So for a same size rooftop, when we try to install using other models, like previously the 158 or the 166, we do see that there's certain limitation. Then when we choose a 210 Vertex S, we are able to actually maximize the rooftop and achieve a higher system capacity as compared to other models. So we can see here, even compared to our competitors, dimension itself is most optimized, where we can offer more flexibility in the small residential rooftop installation, and also reduce some of the overhang risk that might happen if we choose to go with a larger dimension model. So this is one example of the rooftop that we have installed. We can see the modules will fit nicely onto the tight space for a residential rooftop and maximize the capacity that you require. So next will be on our larger footprint modules. So this is available in both the monofacial and also the bifacial module. So this is mainly covering the power beam range from 550, 600 to 600. So these are using the square monoplug cell as also the technology that I introduced earlier. So in terms of high reliability, there's low first year degradation of 2%, and then yearly degradation of 0.55% for monofacial and 0.45% for bifacial. So these are the product details as an example for the 500 watt. So you can see based on the 5x11 layout, and this is using our low voltage, high current design principle. So why is this? Why did we choose this low voltage, high current design principle? Mainly this, we can see the benefit that comes from this design at the system level. So with a lower VOC, we are actually able to connect more modules per string, as shown in this example here. So for this particular site conditions of 1500 volt system, lowest temperature of -10 degrees, we are able to connect about 35% more than others in the per string. So this translates to actually cost savings when we do the calculation in the system level of the VOS. So this is an interesting chart showing that how the system voltage have changed over the last 10 years. So when we started off in 10 years ago, in 2009, we can see that the system voltage only 600 volt, and then we increased to 1000 volt. And then in 2015, we have made the big change to 1500 volts. So this effectively help us to connect more modules per string and drive down the BOS cost. So besides this, we have also worked extensively with third-party consultant agency like DMV to do the simulation. So this is an example of a project that we have done in Spain and USA on a one portrait tracker scenario. So you can see overall the EPC cost will decrease when we use a higher power bin. So this mainly comes from a few of the factors. So when we use a higher power bin, so for the same size system capacity, we'll be using less number of modules. So there'll be less installation work to be done. And because of Trina unique low voltage design, we'll use less strings. So this will translate to less DC cable and wiring work. And at the tracker level, there's also less total length of tracker use. Okay, so these are a bit more details on the savings that come from this simulation report. So if you are interested in the report, do feel free to reach out to Trina. We can always share the report to you for your reference. Yes, and you can see from here the savings from the tracker length and also on our DC cables and also on the labor cost savings in terms of the installation time and less overall work that needs to be done. So not only for one portrait tracker scenario, we have also
不同的支架类型，结果同样显示使用更高的功率的545瓦组件可以获得更低的 BOS 成本。
So we do see that the results are quite conclusive when we use a higher power bin module together with Trina low voltage high current design. We are able to drive down the BOS cost all the different scenarios. So next will be our ultra high power 670 watt module. So this is our 6 x 12 layout. You can see that the size here is about 2.3 by 1.3. Similarly, we are also offering it both the monofacial backsheet and also the double glass bifacial model. Similarly, it's also based on the low voltage high current design concept. So when we first launched this product, we do get a lot of questions, as in because the module size is big. So there is some doubts on the mechanical loading and the other reliability parameters. So to address this concern, Trina here, we have actually done a couple of extreme tests, which include the static mechanical load and 5 other rigorous tests like non-uniform snow load, extreme low temperature, hail tests, dynamic load test, and also the wind tunnel test. So all these tests we have passed and with good results. So if you are keen to find out more, we have the link here that you can go in and download the white paper, which will detail the information of each test. Why are we able to pass all these mechanical load tests? It's because even when we are using a large size module, we have also do changes and optimization to our frame itself so that we have a frame thickness enhancement, a larger frame chamber, and different cross pin and connector design optimization. So this will enable us to maintain the basic IEC requirement of 5,400 Pascal front and minus 2,400 Pascal back. So to also support this larger dimension module, we have also changed our packaging method. So on the left, you can see this is a conventional packing method, which you commonly see, which is the horizontal stack. So for the larger size module, we have changed it into a vertical placement packing. So you can see on the top right corner, this is how it looks like when we open up the package. And inside a 40-foot high cube container, this is how we will arrange it. And you can see that although the number of pallets per container is less as compared to the others, but actually the power per container is higher because of the high power bin of each module. So besides DMV, we have also worked with another third-party agency, Fraunhofer, to do the simulation comparing the different cell size and the different module power. So for G12 here is referring to Trina Vertex module, the 670 watt. So when we compare to the other module size or cell size like M6, M10, the results shows that by using G12 module, which is the 210 mm, we're able to get a lower BOS cost for both the fixed tilt and also the one row tracker. So definitely, the G12 module has the advantage over the others at the system level itself. So to use the Trina ultra high power modules, we need to be looking out for the compatibility with the different inverter suppliers. So on the left is a central inverter, so there's no big issue when we use a central inverter. It's just that we need to upgrade the fuse capacity from 15 amps to 30 amps because of the high current modules. Then on the right is the string inverters. As previously, SMA has also introduced how the different string inverters can work with these high current modules. So we have also worked with the others to make sure that that there is compatible in the market. Then for large scale ground mounted projects, as we know, tracker has been gaining a lot of traction and popularity in the current ground mounted utility projects now. So we have also worked with the various top tracker companies in the market to ensure that even with using the larger modules, we are still compatible in terms of design and can be optimized to achieve the best system results. So lastly, these are some of the case study and examples that we have installed using Trina 210 mm modules. So these are for a rooftop and commercial industrial rooftop application. Then of course we also have ground mounted utility projects that is using the tracker configuration. Okay, so with that, I've come to the end of the presentation. If you do have any question, please feel free to reach out to me, or you can type in the chat box and we will try to address them. Thank you.
Thank you very much, Lin, and also great thanks to our audience for attention and enthusiasm for solar development in Taiwan. Of course, many audience have raised some questions and hoping to get answers from our speakers. Now let's move forward to the Q&A session. The first question is to Mr. Paul J. Kensingham. In terms of your point of view, what is the biggest solar green-fired development hurdle in Taiwan?
I think the largest hurdle that we see is simply the difficulty in the regulatory process of coordinating among all of the different government agencies that have jurisdiction over various parts of the application process. Now, I have to confess that being a lawyer, I see the regulatory headaches, but I don't see the many of the other commercial headaches that that companies face. But in other areas, the Taiwan government has adopted a single window approach that has streamlined the process of various applications and removed a lot of the headaches that applicants face. But unfortunately, in the solar business in Taiwan, there are a lot of regulators who are responsible for a small part of the process, and there's very little or no coordination among the regulators that contributes to delays and to increased costs and to just a general sense of uncertainty.
Yeah, great. Thank you, Paul. And most of the audience are paying attention on SMA product. So, Mr. Charles, could you introduce SMA product for utility scale ground-mounted solar for our audience?
Sure. The utility scale, the ground-mounted for ground-mounted not just the one that we just introduced, the Peak 3, the high power Peak 3, that's the 150 kilowatt. Of course, in overseas market, we also have, like, for example, in Southeast Asia or even in other continent, we also have the Sunny Central product. That's the central unit, as I previously explained, that currently our biggest inverter range reach up to 4.6 megawatt per unit, which means obviously that's a utility scale type of the inverter available. Thank you.
Oh, okay, thank you. And Mr. Lim, which type of solar cell or module technology could be the mainstream in the market for next year?
Thank you for the question. So I think overall, in terms of the solar industry development, definitely high power beams modules are still very much in demand. So we do see that even for next year, the ultra high power modules like 600 watt, 660 watt will definitely be leading the technology. Then of course, we have other new cell technology that's coming in, like the N-type and the HJT. So I believe that probably from next year onwards, we will see that some of the, besides the P-type mono-PERC modules, the N-type will also start to gain more popularity with the customers.
Okay, thank you. And Paul, Taiwan has limited land which is close to for solar power. So what do you think? What's the future about this issue?
I think the pressure is going to be on government if it wants to achieve its solar power goals, to make more government land available to developers. As I indicated in my comments, Taiwan has set itself a goal of reaching 20 gigawatts of solar power by 2025. And as of the end of last year, it's only gotten to 5.8 gigawatts. So any significant growth from 5.8 is not likely to be accomplished by Rooftop alone. There obviously is a shortage of land in Taiwan, but there are plots of land that are owned by the Taiwan government or by government-owned corporations, and some of that land is not suitable for agriculture and could be made available. But frankly, not all ministries buy into the significance of the goal of shifting to more renewable energy sources, and so some of the ministries that do have access to land have not been enthusiastically supporting the transition to renewable energy, and not been eager to give up control of the land parcels that they do have.
Okay, sounds great. So the last question is to Trina Solar. So what technologies are likely to change the shape of the photovoltaic industry in the future?
Thank you for it. So I think overall the trend or the requirement of solar PV projects is still focusing on how we can reduce the system costs and the better LCOE. So definitely the module side, what we can contribute will be in terms of how we can design a module that can help to lower the system costs. So besides from the power itself, maybe like what I mentioned earlier, the low VOC and the different parameters that we can put in to help to drive down the overall costs of the system. Yeah.
Okay, thank you. Great thanks to our speakers for the information sharing, and given that the time is limited. So thank you again. If you have any questions for our audience, you can contact the Lim and Mr. Charles, and also Jorge can see him directly to chat with you, to exchange your opinions about the solar development in Taiwan district. So thanks to everyone joining our today's webinar, and we appreciate all speakers' great support and valuable comments for this market. We will share the recordings and PowerPoint slides used of today's webinar to your registration email by the end of next week. Should you have any questions, please be free to contact our team through the email address showing on the slide on the screen. So please make sure to follow Solar Talks webinar on LinkedIn to get our first-hand webinar update information. Thank you again for attending our webinar today. See you next time. Thank you.